So our next speaker, our next essay is a new cognitive perspective on simplicity in system and product design. It's going to be presented by Stefan Lesser.
Hello, does this work? Is this on? Can you hear me? Is this
Yes.
good? Perfect, okay. So, simplicity, what is that? What does simple mean? I guess we understand these words because we use them all the time, and I heard them here at the conference already many times. Oh yeah, that was simple. Oh, that was particularly complex. But what do we mean by that? I mean, we kind of know what we mean, but it's more of a feeling. It's like we have some sort of intuition about it. We know it when we see it. But how do we describe simplicity? How do we define it? And somehow that turns out to be really difficult, doesn't it? So here's the definition. I guess I forgot to copy that over from the dictionary, but doesn't matter. Also, who does that these days? It's like 2024. It's like ridiculous. So I didn't, well, actually I did, but I can assure you that the rest, there's no slide in here that's been generated by AI. So maybe a quick little bit of background. I'm a software engineer, it's probably not surprising here. I care about these things. And a few years ago, I decided that I want to become a founder and in the tools for thought space. And I was thinking the usual approach, the usual tech approach is that you look at the technology that's available, probably find something that has just become available, it's very exciting and new, and then you ask yourself, okay, so what can I do with it? And I kind of wanted to do something a little bit different. So I thought if I want to create some software that helps people think, maybe I should spend a little bit of time figuring out how thinking works. And this is when I discovered a lot of cognitive science, which is basically an integration of all these fields. And this helped me understand my obsession with human experience that I already had as a software engineer and somebody interested in software design. I was always particularly interested in interaction design and in user experience. And so studying cognitive science helped me expand my view from what I would now consider a pretty limited engineering perspective to a broader cognitive one. And this also shifted my perspective on the topic of simplicity. And what I want to do today is I want to share 5 perspective shifts that I went through that are all grounded in this idea that simplicity must be related to our sense-making, to how we make sense of our world and how we understand things. Because we ultimately consider those things simple that we can understand easily. Okay, let's start with coexistence. So my old perspective on simplicity was pretty straightforward. It's like if you have a complex thing and you want to make it simple, you must get rid of the complexity, right? You remove it and that's worthwhile to do and it's valuable and it's important, so we should do that. But that's not always true, is it? So I noticed that sometimes I really appreciate complexity. For instance, what makes a good movie? So for me, a good movie needs to have a good story. It needs to be interesting. If it's like obvious, then it becomes predictable, and then why would I watch the movie? And I want there to be challenges for characters that they are facing and need to resolve. There should be some surprises, some twists, some unexpected things that are happening. And the characters should develop over time. They should change. So there's a lot of stuff going on. There's a lot of complexity there. Of course, I don't want the opposite. I don't want it to be convoluted and like overwhelming and lots of details thrown at me that I can't make sense of. So, and really good movies, I think, they figure out a way to have enough detail that you can actually watch them again and you discover interesting things that you didn't see before, but they were not in the way when you watched it the first time. So what if complexity is actually what makes things interesting? It just needs to unfold in this comprehensible way so that we're not confused. I think this applies to stories, either in movies or if you read novels. This applies to music, it applies to games, to art. There's usually this process of disclosure that is going on as we are experiencing those things. And it helps us to become familiar with all the complexity that is there, but without being overwhelmed by it. Okay, so of course, at first I thought this must be about balance then, right? It's like a fine balance between, we need to hit the sweet spot. So we have to still reduce complexity or keep it low so that we can achieve more with less and we limit ourselves. So we don't create those convoluted messes that nobody can understand. But then I wondered if complexity unfolds in an intelligible way so that we can follow, is there a limit? Where is that limit? Here's an example from video games. I'm a huge Zelda fan. I played Breath of the Wild during the pandemic, which helped me stay sane. And now I play Tears of the Kingdom. These are very complex open world role-playing games, if you're not familiar with them. I think they are brilliantly designed. And the whole fun is to discover their complexity. There is a story that you can follow, which is pretty straightforward, but there is so much more that you can do in those games. And you can just explore the world, and there is endless stuff to do. So they are really complex. So can things be complex and simple at the same time? What if simplicity is not the absence of complexity, but the superior organization of it? And if that's the case, then it might be more important than avoiding or reducing complexity might actually be how we organize it. Another way to visualize this is that my thinking went from a very simplistic one-dimensional spectrum with like simple on one side and complex on the other, where you just look for the sweet spot somewhere in between, to a more sophisticated two-dimensional model, where we now also have a dimension that measures how well organized the complexity is. So on the horizontal axis, we have basically how easy is it to describe and perhaps to make the thing. I call this mechanical complexity. And on the vertical axis, we have how easy is it to understand it, to enjoy it, perhaps to use it. And I call this experiential complexity. This still gives us the classic categories, if you will, where something is simple on both accounts, which is trivial, perhaps boring, perhaps useless. And we also have the opposite, where something is complex on both accounts, where it's very intricate, confusing, and it might be very powerful, but it's very hard for us to figure out how to make use of that power. But now we have these two other quadrants that are very interesting, I think. So we have one where something is easy to describe, but hard to understand. Math, probably, for most people. But we also have this other one, which is the opposite of that, which is like something that's very hard to describe or make, but very easy to understand. And this is where I believe all those great movies, stories, art, and games live. And this is also where I believe good software with great user interfaces and user experience lives. And the way those things manage to accomplish this is that they are hooking into stuff that we are intimately familiar with. This could be either direct experience, so you've encountered something before, so now you're familiar with it, and so now you kind of know, and it becomes easier for you to understand. But it can also happen indirectly through something like metaphors or analogy. And this is, I think, where it gets interesting. We use this, of course, in computing with user interfaces, where buttons look like buttons from the real world, so we could transfer some knowledge over. Kinetic scrolling is maybe a more recent example that we do all the time on our touchscreen devices, which taps into our familiarity with physics, because we live in a physical environment, and this just feels very natural. You don't really have to explain to people how to scroll. But now you have to simulate physics, on the other hand. So there is this thing with great user experiences where we often have to buy the experiential simplicity with mechanical complexity. So we have to do a little bit more work on the making side to make it easier on the using side. So there's tons of there's tons of research on cognitive processing. I picked just a source here that I'm pretty sure that many of you are already familiar with because it has become so popular, and this is Daniel Kahneman's Thinking Fast and Slow, where he talks about two kinds of cognitive processing. There's system 1 and system 2. System 1 here on the right is intuitive. This is something where we experience something that comes to mind instantly and it just makes sense. This is fast, this is automatic, we use it all the time, it can be emotional, it relies on stereotypes, and it happens, most of the work happens unconsciously. We basically just get the result of this process surfaced in our conscious mind. And we use intuitive processing to make sense of something intuitively, and this is what I think is related to experiential complexity. So something is experientially simple, regardless of how difficult to describe or make it is, when we instantly get it. System 2 is analytical, so when you actively think through something or reason about something. It's slow, it's effortful, we use it only when we need it, it's based on logic, it's calculating, it's mechanical, almost algorithmic. And it happens very consciously because we have to be really concentrated, we have to be focused. So we use our analytical processing to describe and define things. And this is, of course, related to mechanical complexity. And something is mechanically simple if it's easy to describe or make. So the idea behind those two systems is that we have both of them because our intuition is super fast and we use it all the time, but sometimes wrong. And so we have this other system where it can analyze the situation and then potentially correct our intuition. So this means that we can now truthfully state that something incredibly complex mechanically can at the same time be amazingly simple experientially. And this means simplicity and complexity can coexist in the same thing. Let's talk about relationality. So I've now pulled the observer into the model of complexity. That means I've just tied complexity to cognitive processing, and therefore I also have tied it to subjective experience. Now, obviously, we try to usually avoid subjectivity in favor of like objective properties that can be verified independently of any observer's particular abilities. So that's a problem. So on the mechanical complexity side, where we have simple things that are easy to describe and reason about analytically, we can kind of get around this. We can find objective, universal definitions for mechanical complexity, which is practically what we have done in the past when we were trying to define complexity, which is usually based around something like the number and kinds of components and the number of connections between them. So we're kind of okay here. But then we have this other thing where simple things can be coherent and intelligible so that they make sense to us intuitively. And this is rather subjective. So this is tied to the specific cognitive processing of a particular observer. And this means that it's tied to how familiar this observer is with certain concepts that are needed to make sense of it. So how do we deal with that? Well, it turns out that in psychology and design, this has been identified as a problem before. So I want to talk to you about affordances a little bit. So what's an affordance? This could be an affordance. So this is supposed to be a door handle. Just making sure. So if you see this attached to a door in the real world, then it's obviously an actual, real physical structure. So there's an arrangement of atoms that you identify as a door handle. But that does not make it an affordance. Because the other thing that's needed for it to be an affordance is there needs to be a subject that perceives this particular arrangement of atoms in the environment. And this observer needs to have a subjective, phenomenal, and mental experience. Because then it is the hand that we can use to actually manipulate the door handle. It doesn't really make sense without that, and it's not really an affordance without that. So it becomes an affordance through our cognitive processing and our sensory motor capabilities to interact with it. So it's kind of neither purely objective, but it's also not purely subjective. It relies on the relationship between object and subject. And this is what I mean by relational. James Gibson says that an affordance is equally effect of the environment and effect of behavior, and he also writes about how this cuts across this dichotomy of objective and subjective. And I would argue that simplicity is analogous to that. So it's also relational because it's grounded in this relationship between object and observer. Now let's look at this in a little bit more detail, and let's look at the objective side, the mechanical complexity side first. This is the mechanical complexity. We detect physical structure, and if we want to make something mechanically simpler, we have the option of modifying the organization of the structure. So for instance, we could reduce the number of elements, and that hopefully makes it simpler. But the point here is that we can change the thing. We can change it. And this means it applies universally, because if we change the thing, it doesn't matter which observer comes along, they will all have the same new experience of the changed thing. On the other hand, the subjective part of experiential complexity means that we're projecting our own mental experience on this. And this means that we're projecting our familiarity on the thing. This is, of course, something, if we want to make something experientially simpler, what can we do? Well, we have to become more familiar with the thing. We can learn about it, we can practice with it, we can grow under our understanding of it, but we have to change us. And this is the thing that does not really scale because it's always particular, because every observer has to go through this process by themselves. So I want to relate this more to our industry. So if you think back to what you heard about the 1960s to 80s, just before the commercialization of personal computing, basically the first personal computing systems, they did not really make a distinction between users and programmers. If you were a user, you were the programmer, and vice versa. There wasn't a distinction really. And these systems have been designed with this thought in mind, or without this thought of distinguishing between them. You were kind of expected to build your own tools, and you were dropped, as soon as you switched on those computers, you were dropped into a very limited programming environment, basically. So, and you were expected to make the thing that you wanted to use. But then we figured out a clever trick. We, of course, knew before that we can use things without really understanding how they work. We rent houses, we drive cars, we use computers today, and we don't have to build them ourselves if we don't want to. We can just buy them and have them built by somebody else. So we had this really good idea of separating users from makers. And the good thing for the user is that they can ignore a huge chunk of mechanical complexity that they just don't need to be bothered by, and they instead just have to become familiar with the interface. And this is usually orders of magnitude easier, especially today, where all things are really, really complex. And then we can enjoy utility, convenience, automation, all these nice things as users. On the other hand, makers can specialize on this mechanical complexity. They can become experts at implementation. And this is where we can utilize our analytical abilities to the fullest. So we can figure out how to deal with all this mechanical complexity. And we can live happily ever after and have all this useful stuff. Most of us don't need to know how to build it. Most of us don't even need to know how it works. And we can all enjoy convenient utility at scale. Let's look at feedback. So we have doubled down on mechanical complexity and look at all the progress that we have made. So this, of course, didn't start with computers. That's just an arrow that's representing progress. Don't read too much into it. So we can look back at 3 centuries of progress. Maybe if we start with the scientific revolution, then we had an industrial revolution, then we figured out computers. And today now, we live in a world where we can't put away our devices and software is eating the world. But we didn't just invent technology. We also have created powerful incentives where we have commercialization, capitalism, which created this powerful flywheel where we can now manufacture and distribute pretty much anything, pretty much anywhere. And now we live in this consumerism world where it is so much more convenient to just buy a new thing instead of repairing a broken one. That's what I mean by progress. We created so much value, and aren't we so much better off today? So a lot of this progress rests on a single assumption, and this assumption could be called Descartes' one weird trick, where he basically said we can consider everything as a machine, because we can take it apart, we can analyze it, and then we can put it back together. And this is, of course, looking at the mechanical complexity of things exclusively. And it turns out that we have become really good at this. We have become so good at this, I would argue, that this has now snowballed into a worldview. And perhaps the default worldview that we all have. It's so deeply embedded in our culture that this is practically what we mean when we talk about progress. It's that we can fabricate convenient utility at scale. And if you listen to the people that make a lot of money from this, they can tell you that there is yet more convenience and yet more automation to be had. Because everything can be automated eventually. Because everything is a machine, perhaps including us. Here's what Christopher Alexander thinks about it. It's a long quote that I didn't want to cut from this presentation, but we don't have enough time, so I will skip over this. So if you're watching this as a video, pause it now, and if you're in the live audience, I'm sorry. Reality sucks sometimes. The gist, though, is that the mechanistic worldview relies on this idea that everything can be a machine, and it's very goal and results oriented, because that's what machines are. They are built for a particular thing, for a particular outcome. And so we reframe everything as a problem that needs solving, and we're obsessed with productivity, with efficiency, with metrics, and with scale. And just notice how well this fits our analytical processing. We can reason and predict logically along causal chains, and we create models of reality with the aim to control and manipulate our environment. And the way we deal with surprises is that they are seen as failure, because they usually indicate that our models are not accurate. And so we need to go back to the drawing board and figure out a better model. I also think that this worldview has given us quite some overconfidence in our ability to predict and plan things. Now, what could an alternative view look like that maybe fits our intuitive processing a little bit more? So I call this the developmental worldview, if you will. In the paper or in the essay, I'm actually talking about systemic, because this has been very much inspired by dynamical systems theory, but I think today developmental is perhaps a better way to understand this. So the developmental approach is process-oriented, because the goal might be unclear. We might not know what the goal is yet. And the point is to figure out and make sense of the world. And we're more interested in accuracy and fitness, in efficacy, and we just follow hunches and we make mistakes along the way. But we do grow in a developmental sense. We grow our understanding, and we become familiar with things. This, of course, requires feedback, and this is why this section is about feedback. We know that our understanding is incomplete, and so we know that we need to discover and explore things. And we also realize how limited we are in controlling things, so that we rather seek to influence and transform instead and watch what happens. And the way we think about surprises in this process is very positive, because surprises often cause important insights. And this is a clear indicator that we're actually learning something. Now, I'm obviously an industry guy, so I might not be an expert on this, but this looks like science to me. Because you're not trying to solve problems, you're trying to make sense. You're not publishing papers to appear productive, right? You don't care about metrics like citations. It's all about the quality of the theory. And when you apply for funding, then they know that you have to discover and explore things. So they don't ask you or force you to reason and predict about outcomes and schedules, right? This is how science works, I hope. So from an industry perspective, I have to say, despite our best efforts, we also have figured out at some point that we can't really ignore the environment completely, and we came up with incremental and iterative approaches or agile methodologies. And I think they nudged us in a good direction, but I don't think we have changed our mindset at all. And I think we're still very much stuck in this mechanistic paradigm. It's just now that we have time-boxed sprints and story points as well. So I really believe that we cannot reach simplicity mechanistically. We have to rely on deep understanding, and we need to explore the space. And we can't really plan our way to simplicity. We need to learn, we need to grow, we need to become familiar with the details, and we have to have those surprising insights that may help us figuring out simpler things. Okay, the last two I want to cover together, and I want to specifically look at the software industry here. So I talked earlier about this distinction between user and maker, and where the main benefit is that users don't have to deal with all that mechanical complexity. In the software industry, I think we have taken this even further. We can now scale our capacity to deal with mechanical complexity by selectively ignoring it. So we isolate components and modules, and then we can apply this divide and conquer approach to them, which means that we now have other team members, other teams, or perhaps even other organizations, just selectively focusing on one component and being able to ignore all the others. And then we also look for reusability, so that we can do something once and then we can reuse it in different contexts. And all these things taken together enable this impressive scale that we have reached. But I want to point out that all the complexity is still there. We're not removing any. And I would argue that we are even adding a lot more to it, because we're just hiding it behind interfaces that get wrapped in perhaps reusable components. And then we end up in these complex dependency networks, which at this point, of course, transcend organizational boundaries. And we get caught up in business models that are trying to extract value from this dependence. And the things that we depend on, all those components, are either completely opaque and we just accept that, or they are theoretically transparent. And what I mean by that is, yeah, it is great to have access to source code and to look at the implementation. But it's pretty worthless if you're not familiar with it, and becoming familiar with it is the hard part. So what I'm basically saying is that we have created this culture where we are cultivating ignorance, and it's okay that you don't know how most of your technology stack works. Don't worry about it, just keep shipping features, right? And what can I say? We talked about this a lot today. It only gets even better. Generative AI is coming, or is already here. So you don't know the framework, or you don't know the programming language even. LLMs have you covered, and they can write the code for you. Perfect. So we can now understand even less. We can ignore even more, and we can yet be more productive. How this will, of course, impact the quality and simplicity of the solutions that fall out of this process, I'm not sure about that, but I would bet that nothing is getting any simpler. Everything is just getting more convenient. But let's not confuse convenience with simplicity. So let's talk a little bit more about the mechanistic perspective. And of course, we are interested from that perspective in modularity and scale. And the products and the software that we build, we want that to scale, right? So this means it needs to be somewhat generic and universal and context independent. It needs to work in general, and we want to address a large market with that. So it will never be quite perfectly adapted to us, and we have to accept that we will have to adapt to it. It is just good enough. It is not perfect. And this is what I would consider tools to be. We talk a lot about tools in software, but I think we use that term for a lot of things that I don't believe are tools. But tools for me are fundamentally mechanistic, but this is a good thing. We want tools to be like a machine. We want them to be precise, reliable, and consistent. And we adapt to them happily by understanding what they are for, and then we can use them appropriately for whatever context we're in. So, and we also want to have several tools to us available to us so that we can choose the right one for the right job. And that they are somewhat static and closed and best for one use case is actually a good thing, because that's how we choose them for a category of tasks. Yes, you can use a hammer for a lot of things, but it just works best with a nail. So tools that do all these things pretty well have the chance to become popular. And this is, I think, the measure of success for this mechanistic perspective. But of course, there is the developmental one. And in this perspective, we value things that adapt to us and become very specific and particular, perhaps even unique to us, where we are not talking about just good enough, but about exactly right. Every realistic answer to a question usually begins with the words, "it depends." And this is what context sensitivity is. This is situational awareness. This is about respecting the environment. And this is why I like to make this very clear distinction between tools and environments. So good software, first of all, we use tools, but we live in environments. And a lot of software that we use today, I would say, we live in. And so they are not tools, they are environments. And we should get this distinction right. Because good software environments allow us to choose different paths to reach a goal. They are ambiguous in that way, and that's good, because everybody can choose their own path to do what they want to do. They offer surprises, they have functionality that maybe we haven't expected to be there. They are flexible, they are configurable, customizable, and they can become unique to us. And they are open to extension, and great environments make us feel like we belong there. So we've become so familiar with them, and in a way they have become familiar with us because we have made them adapt to our unique requirements, that the measure of success for those things, for those environments, is not popularity, but it's belonging. So maybe keep that in mind next time you find yourself in a debate about Vim or Emacs. Tools absolutely have a place in environments, and so we buy power tools and we arrange them in our workshop. And I don't think we need more tools necessarily, we need the right tools. And the right tools can then become part of this environment that we're in and that we want to live in. And that's an environment that fits our needs, that adapts to our requirements, and it's one that we understand, that we can become familiar with, that we want to become familiar with, that is worth becoming familiar with, and which is perfectly adapted to us. I'm worried that we're losing our balance here because we are missing the forest for the trees. We're kind of missing the environments for all the tools that we constantly talk about. We're also ignoring a lot of the classic papers that have already tried to make us aware of how important understanding our environment is. Here's just a quick one. Programming is about insight, about forming a theory from programming as theory building. Simplicity is the most important consideration from versus better. Complex systems reflect our immature understanding from Big Ball of Mud. The incomprehensible should cause suspicion, not admiration, from a plea for lean software. Understanding a system is a prerequisite for avoiding complexity problems from out of the tar pit. And there's lots more, but you can see I ran out of space. So all of these point towards the importance of developmental growth, that we need to take time to explore. We need to take time to become familiar with things. We need to look under the hood beyond the interface, and we need to understand how things work. And it's ultimately essential for discovering simpler solutions. I'm worried that we have convinced ourselves that we found a shortcut by cultivating ignorance, and I don't believe that there is a shortcut. Okay, so this is how I think about simplicity today. And there's so much more to explore and discuss. I came across so many fascinating ideas in cognitive science that I believe can help us with this more systemic developmental understanding of ultimately unpredictable but adaptive dynamical systems, because cognitive science is trying to understand the most unpredictable dynamical system of all, us. Of course, I had to limit myself today here so that I don't overwhelm you with complexity, and I hope I managed that I have unfolded a comprehensible story that you were able to follow. You'll find a little more depth, of course, in the essay, and I also have a Substack where I write about this. But there's one question that, of course, remains. What can we do? I mean, to try to give an answer to that question, I want to come back to the very first perspective shift that I talked about coexistence, that simplicity and complexity can coexist. I believe that everything has to start here. So today I've been communicating to you in literally black and white terms, I wanted to polarize, to clarify. And I wanted to clearly differentiate the options that are available to us. But not once in this presentation was anything on the black side bad. If you missed that detail, I encourage you to watch it again. So this is not about choice. This is not mutually exclusive. And to become good at one of those things doesn't mean that we can also become good at the other. However, at the moment, of course, I believe that we are orders of magnitude better at one of them. So they don't compete, they complement, they need each other. I think we need both, and we need to integrate them. Ellen Kay yesterday was saying in the interview, was talking about a sign at Bell Labs, I believe, that said something along the lines of like, you either do something useful or you do something beautiful. Why not try both? There is beauty in simplicity, I believe. So I really believe that we have this capacity in us. We're using it all the time. It's part of our humanity. And it's just so intuitive that we are not consciously aware of it. So let's not lose faith that we have something to offer that machines don't. I'll leave you with this, which I've taken from one of my posts on Substack. And yeah, if anything today that I said resonated with you, then please check out the Substack and please reach out, either through Substack, through email. I'll be on the Discord, and of course I'm happy to take some questions now. Thank you.
Thanks for that. Whoops, am I here? Yeah. Okay. Thanks for the talk. It was great. I feel like I could have a conversation with you for a long, long time. But one of the things that I was thinking about, because I've been lately doing some work with Kahneman's work for helping social workers understand and navigate that their problems and their day-to-day kind of challenge that they deal with, and there's definite analogs to software developers. The thing is, it isn't fast or slow, as you said. It's not. They're working both at the same time, but they have different energy needs. And having reactive, intuitive things are great, but we have to tune them. But we also need this sort of, I'm going to say, if things don't seem right, we need to step back as designers and say, wait, my slow thinking is always going on in sort of idling mode, looking on at things, so I need to listen to it rather than just going fast. So one of the challenges, I think, when you're talking about integrating with tools or with, is how do I develop those sensitivities to back off, because that intuitive side of design is kind of addictive. So, any thoughts about that?
Yeah, I mean, I think a lot of the difficulties lie in this asymmetry between how those systems work. And I think becoming aware of that there are those two things and that they are happening is the first step. And I'm not sure how. So you're talking about the intuitive system being sometimes more addictive than the analytical one.
Yeah.
Yeah. I mean, I wish. For the software engineers that I know, I wish that they would realize that. But
well, it's like the rush of test-driven development and little emotional things. I'll just go with it. This is cool. This is a rush. Is this a good design? That's the kind of pausing and that we have to think about. And I think awareness, if reading Kahneman, is like awareness isn't enough.
Yeah,
but
totally.
It helps.
Yeah.
Yeah.
Yeah, I also think, this is the thing, if you are actually familiar with Kahneman's work, then this might not be the best example for my interpretation of the topic, because I think he is also a little, he might be critiquing the intuitive part a little bit more.
Oh yeah, he's judgmental. I definitely agree.
Yeah, but there is a lot more cognitive science that I didn't talk about, where I think we're getting more and more and better understanding of the intuitive parts and how that works, and how there is potentially a lot more work that is being done that we're just not aware of, that helps us. There's, I mean, my favorite topic is relevance realization, and there's something called opponent processing, and there's a lot of stuff in dynamical systems theory and complexity theory that is coming up recently that is super interesting in trying to figure out what might be going on in these processes. And it all points towards that we are really good at figuring out what is relevant, but not in an analytical way, but in a subconscious way.
Yeah.
And like to bring it back to the design process that you were talking about, I think the only thing that we can actively do, I think, is we need to just be aware that we need time, and we need to have those periods where we are just going with our intuition for a while and then just see where this leads us. And then we go back to the analytical one and try to judge it. And we need to reserve time for that. But the problem is that we usually, of course, don't have that time because the incentive structure that we are part of does not support that.
Yeah, software engineering is a machine. Yeah.
Like everything is.
Yeah, thank you.
Hi, I've been trying to figure out how to simplify my question, but you mentioned towards the end that you think we all need to look under the hood. I'm really wondering who you meant to look under the hood and what you expect people to see. I mean, I was trained as an engineer and I'm a computer scientist, but if I look under the hood of my car now, I even have trouble figuring out which part is the engine. And I was trained on how to do internal combustion engines. I still can't figure it out. I'm working right now on a project where we've spent a lot of time trying to address the needs of users and provide something that is straightforward to the users. And yet, as we do that, what we're finding is if they look under the hood, it's much more complicated than what they had before. And we start making trade-offs to say, well, we're having issues with implementation. Well, if we change that, we're going to lose this user feature. So you'll always have these engineering trade-offs. And in the end, the people using this don't really want to look under the hood. And if they do want to look under the hood, it's not going to help them, it's going to make them scared. Just like me looking in the hood of my car now. While I get a lot of benefit from the way the car works. So the question is, who looks under the hood and who decides what is simple? And when you can't always integrate, how do you make the trade-offs?
Yeah, it's so what I tried to actually there was a much better slide, not in my presentation but in the presentation before, where you saw this like trajectory of the last 50 years or 70 years of computing and how we were using these 70 years to constantly make more complex things but give them simple names and then just shove all the complexity under this name. And so we live in this world where we now have like incredibly complex things that if you open the hood, it's like it's shockingly complex. And I don't think this is part of the problem. We have been living with this for so long that we have figured out these ways to scale that we now have incredibly complex systems. And I mean, I personally would say that we probably need to go back to the drawing board and start from very simple ideas and from very simple systems and maybe throw some of the stuff that we have today away. But this is, of course, unthinkable in the incentive structure that we live in. So how do we do that? I don't know. This is the hard part to figure out. But I do believe that, especially because there are so many projects where software engineers are just experimenting, just having some hobby projects where they just try to rebuild some of the infrastructure. And just in a playful way, they're not expecting this to become load-bearing at any point. I think that there is some potential to discover simplicity that we haven't discovered before. The problem that we have today, I think, is that because of all the complexity that we're deeply ingrained in and entrenched in, is that it's hard for us to, I mean, even if we wanted to, we could not have a single mind like comprehend the whole technology stack. It's just not possible anymore. And maybe that's maybe that's okay. Maybe that's ultimately the scale that we're operating right now. Maybe that's okay, and we just have to accept that we need our collective intelligence, where we at least split a little bit of the work into like different teams and heads. But the big question to ask then still is, do we need it to be as complex as it is today? And do we need it to be as complex? Is there really not a possibility to find something simpler? But we cannot find out today because everybody understands just a tiny part. Like all the experts just have a tiny part that they understand. And for simplicity, you need holistic design. You need to at least have a better overview of more than just the tiny parts that you know today. And yeah, that's the challenge, I think, to broaden your knowledge and your familiarity with some of at least the layer below, the layer above, or like some stuff that's quite next to you. Yeah.
Thank you. Just one quick comment. You have a very nice idealization of the way science works. But I also publish in physics, and unfortunately, the incentive structure is pervasive there also. The push to publish, the number of papers, and the fact that to get funding, even in theoretical physics, let alone experimental physics, you can just do incremental improvements. So this isn't just a problem with us, it's pretty pervasive in our society.
Yeah, I'm not surprised.
Yeah, on that note, I will sign up to endorse the position that has been advocated so often here that counting papers is the wrong way to evaluate the quality of good research. But I really wanted to ask about the dynamic character of simplicity, that simplicity is not an intrinsic property of an object or an entity, but something that you might manipulate on its own. Alan Kay once famously said, there wasn't room for this on your slide, that point of view is worth 80 IQ points. And my question is really about the possibility of theory formation, where the theory formation simplifies something that originally appeared complex. To pick an example out of our field, you can get books of recipes for stews and soups. I had once a book called The Impoverished Graduate Student's Guide to Eatery or something like that. And they said, okay, so a casserole has a pasta thing and a meat thing and a sauce thing. And by giving you this insight, you now don't need to read all the recipes and execute them individually. You can say, okay, I need I guess it was a starch thing and a sauce thing and a meat thing, and the starch might be rice or pasta or what else. So from that, there's an extracted simplicity that comes from forming a theory that is in itself simpler than all of the examples, and it helps to understand the examples. Can you comment on how that extension works to the things that you've said?
I could try. Somehow what you just said reminds me of this distinction. I told you that I read a lot about cognitive science, which has also philosophy in it, and I read a lot about wisdom and the difference between knowledge and wisdom. And I think this reminds me a little bit of that. So knowledge is the stuff that you can capture in recipes and where you just need to know, where you just basically need to know some propositions, facts, and then you can use them. And that's obviously useful. I mean, there's nothing wrong with that. But there's this other thing that we as humans are capable of, which is wisdom, which is kind of like, it's hard to explain where exactly the differences are, and there's lots of different definitions of both of those things. But for me, at this point, wisdom seems to be a little bit on a higher level, where it is utilizing knowledge, of course, as part of it, but it's more about how you apply knowledge and to know when to apply which knowledge and in which situations. So there's all the context dependence that comes into that. And for model formation and theories, you want to be, this is again like the distinction between the mechanical sides of this. We want to take advantage of universal theories that are applicable in most contexts or all contexts, ideally. But then we also are aware that we have to adapt things to specific contexts, or that some things just don't apply in specific contexts. And I think this is the wisdom part, where you always have to combine knowledge with the wisdom and the rationality in the original sense of the word ratio, how much of which is the right thing in this particular situation that I find myself in. Theories still help with that, and they're still very useful for that, and all the universal generic facts that we can figure out about our environment are extremely helpful, but I think we're a little bit over-indexing on just always looking at that and not so much looking at the context-sensitive wisdom that we need.
Thank you for that insight. As you were talking, I realized you've put your finger on the limitations of generative AI. That they are lodged in the wisdom side of that distinction, and not in the lodged in the knowledge side of that distinction, not the wisdom side.
Yeah. Yeah, I mean, you also talked about tacit knowledge, and I feel like there is probably something of that tacit knowledge that we can still put into propositions, write down, and share. But there is a lot of tacit knowledge that is actually not propositional. So there is this model. Which I love, and if we have another minute, I will quickly run you through it, of 4 kinds of knowing from John Vervaeke, where propositional knowledge is just one of them, and the other 3 kinds that he talks about perspectival, participatory, and procedural knowledge, are all not really, they're kind of like tacit knowledge. They are not necessarily, we cannot write them down. It's like riding a bike. Like, how do you ride a bike? You need to experience it yourself. That's one of the examples for that. So there's interesting models that can help us understand better that the world is not just, or at least our mind is not just working based on facts like machines do today.
Well, thanks a lot. Let's thank the Stefan one more time.
Thank you. Thank you.
I saw you start a big ball of mud.